Evaluate the integral of x cubed log x base e with respect to x. This is the same as x cubed ln x. We can write this as the integral of x cubed log x base e is the same as ln x. Now, we know that there's no standard integral for ln x, so it's better to make ln x u and make x cubed dx dv. So let u be ln x and dv be x cubed dx. So that simply means du dx is equal to 1 over x, and v is the integral of x cubed dx, which means du is equal to 1 over x dx, while v is equal to x raised to the power 4 over 4 plus c. Now that therefore means that the integral of x cubed ln x with respect to x is equal to uv, which is ln x times v, which is x raised to the power 4 over 4, minus the integral of v du. V is x raised to the power 4 over 4, and du is 1 over x dx. That's times 1 over x dx, and that's equal to x raised to the power 4 over 4 ln x minus, I can write this as x here 1, x here 1, x here x cubed, and that will be minus the integral of x cubed over 4 dx. This is an x cubed over 4 dx, which simply means x raised to the power 4 over 4 ln x minus, I can bring out the 1 over 4 multiplied by the integral of x cubed dx, and that's equal to x raised to the power 4 over 4 dx minus 1 over 4 times x raised to the power 4 over 4 plus c. And finally, the answer is x raised to the power 4 over 4 ln x minus 1 over 16 x raised to the power 4 plus c. Or if you like, you can write it as x raised to the power 4 over 16. And that's it, very, very simple. Now, evaluate the integral of x squared sine x dx. The technique here is also integration by parts. Let u be equal to x squared and dv be equal to sine x dx. So that means du is equal to 2x dx. Of course, du dx is 2x. That means du itself is 2x dx. And v is the integral of sine x dx, which means the integral of sine x is minus cos x. That's minus cos x plus c. And that simply means the integral of x squared sine x is the same as uv. U is x squared times v, which is minus cos x, minus the integral of v du, which is minus cos x. Du is 2x dx. So that's minus cos x times 2x dx. And that's equal to minus x squared cos x. Minus times minus is plus. That's plus. I can bring these two outside to make it the coefficient of integral. And I'll be left with cos x times x dx, which I can write as x cos x dx. I brought out minus 2. If you multiply by this minus 1, you get plus 2. And you'll be left with, and inside here, we'll be left with cos x times x. which is the same as x cos x, and then you have a dx. So now what's the integral of x cos x? Let's do that separately somewhere. The integral of x cos x, we're also integrating that by parts. That's also to be done by the technique of integration by parts. So let u be x and cos x dx will be dv. So the answer will be uv, which is x times, this is dv, cos x dx is dv. If dv is cos x dx, that means v is the integral of cos x, which is sine x, minus the integral of v du, which is sine x, and du, if u is x, du will be dx. So that simply means x sine x minus the integral of sine x, which is minus cos x plus c. And that's finally x sine x plus cos x plus c. So that's the integral of x cos x. So this simply means minus x squared cos x plus 2 into brackets x sine x plus cos x, x sine x plus cos x, and you put just one c, and that is, let's take this out. So that's let's check that again. I have the integral here. That's correct. The integral of x cos x is x sine x plus x sine x plus cos x. So now that's what we have here, and we simplify further to have x squared cos x plus 2x sine x plus 2 cos x plus c. And that's it, very, very simply. Now to E, evaluate the integral of e raised to power 2x cos 2x. Let u be equal to e raised to power 2x and dv be 2x, no, be cos 2x, this is dv, cos 2x dx. So this is u, so that means du dx is, if you differentiate e raised to power 2x, du dx is 2 e raised to power 2x. That simply means du itself will be 2 e raised to power 2x dx, and v is the integral of cos 2x dx, which simply means, which is equal to the integral of cos 2x dx, if you check that, is 1 over 2 sine 2x plus c, 1 over 2 sine 2x plus c. So that therefore means the integral of e raised to power 2x cos 2x is equal to uv, u is e raised to power 2x, times v, which is 1 over 2 sine 2x, or I can write it simply as sine 2x over 2 minus the integral of v du. V is sine 2x over 2, and du is 2 e raised to power 2x dx. So 2e raised to power 2x dx. Now that simply means, now we have to, okay, here 2 cancels 2, and I'll be left with e raised to power 2x sine 2x over 2 minus the integral of e raised to power 2x sine 2x dx. So now this is what I'm going to do separately. What is the integral of e raised to power 2x sine 2x? Let's do that here. E raised to power 2x sine 2x. What's the integral of e raised to power 2x sine 2x? this simply means let this be u and this will be dv. So that means uv, which is e raised to the power 2x times v. The integral of sine 2x is minus cos 2x over 2 minus the integral of v du, which is minus cos 2x over 2 du. If u is e raised to the power 2x, du is 2 e raised to the power 2x dx. So that simply means e raised to the power 2x minus e raised to the power 2x cos 2x over 2. 2 cancels 2, and we're left with minus, and minus is plus. So we have plus the integral of e raised to the power 2x cos 2x dx. So we see that this integral has occurred again. Yeah, that's what we are. That's the original integral. That's the original function that we're integrating. So we can bring it here. So that simply means the integral of e raised to the power 2x sine 2x is the whole of this. So let's put it there. So that simply means e raised to the power 2x sine 2x over 2 minus, open bracket, minus e raised to the power 2x cos 2x minus e raised to the power 2x cos 2x over 2 minus the integral of minus e raised to the power 2x cos 2x plus the integral of e raised to the power 2x cos 2x plus the integral of e raised to the power 2x cos 2x with respect to cos 2x dx. And now what do we have when we open the brackets? We have the whole of this represents the integral of e raised to the power 2x sine 2x. So what's the next thing? That's e raised to the power 2x sine 2x over 2. When we open the brackets here, we have plus e raised to the power 2x cos 2x over 2 minus the integral of e raised to the power 2x cos 2x. Now, so we can take this out. Now, so that's what we have. That simply means the integral of e raised to the power 2x cos 2x is equal to the whole of this. So we can bring this to the left hand side. We can bring minus the integral of e raised to the power 2x cos 2x to the left hand side. When we do that, we have the integral of e raised to the power 2x cos 2x e raised to the power 2x cos 2x dx plus, when this one comes to the left hand side, it becomes plus the integral of e raised to the power 2x cos 2x equals, I will be left with this on the right hand side. That's e raised to the power, I think I should write it on the next line, will be equal to e raised to the power 2x sine 2x over 2 plus e raised to the power 2x cos 2x over 2. And that simply means 2 times the integral of e raised to the power 2x cos 2x dx is equal to e raised to the power 2x sine 2x plus e raised to the power 2x cos 2x over 2. And that simply means Therefore, the integral of e raised to power 2x cos 2x dx will be equal to e raised to power 2x sine 2x plus e raised to power 2x cos 2x over 2. What I'm doing now is I'm dividing both sides by 2. Divided by 2 will now be times 1 over 2. And that simply means e raised to power 2x. I can write it this way. 1 over 4. Let me write it this way. E raised to power 2x sine 2x plus e raised to power 2x cos 2x all over 4 plus c. And if you like, I write that 1 over 4 into brackets the whole of this numerator. And that is it very, very simply. That's it very, very simply.